quadratic equations. In this lecture, we are going to learn about the fractional rational function. Okay, fractional rational function. So what is a fractional rational function? If any function which is in the form of some polynomial in a ratio of polynomial in x to another polynomial in x, okay, then that function is called as fractional rational function. And the polynomial in x by polynomial in x can be of different ways. So what it is, y equals to the function y equals to, it is a linear expression by linear expression. Like, what is the example? For example, a linear expression ax plus b by cx plus d, okay, and or which is the type of linear by quadratic expression, okay, linear by quadratic expression. So the example is, which is in the form of some, for example, some px plus q by, so ax square plus bx plus c, or otherwise what it is, some quadratic by ratio of a polynomial, some quadratic expression to linear expression. So the example, ax square, which is in the form of ax square plus bx plus c by px plus q, and another one is which is in the form of quadratic by quadratic, okay, which is in the form of, so quadratic expression by quadratic expression. Okay, so the example, we need to consider the two quadratic expressions. So like a1x square plus b1x plus c1 by a2x square plus b2x plus c2. Okay, so these type of functions are called as fractional rational functions. And what are the use of these functions? These functions are used to find the range of, okay, range of the function. That means here the function we are considering it as a range of y. Okay, these are used to find the range of the given function. And what is the range of a function? So range is the set of all possible values of y. Okay, the range is nothing but set of all possible values of y. And we can get, how we can get the values of y, we can get by putting, that means by substituting all possible values of x. Okay, all possible values of x. Okay, here we will put some values of x. For these values of x, all possible values of x are substituted over here. For all possible values of x, the values of y, what we get, the all possibles of values of y, what we get are called as the range of the function, range of the function. So simply we can say that, so y is an output to a system, whereas x is an input to a system. So by applying the inputs to a system, and what are the outputs we are obtaining from the system, that are calculated with the help of these fractional rational functions. So these are used to find the range of the given function. Now we discuss how to find out the range of the given function, which is in the form of a linear expression by linear expression. So let's consider the example, y equals to ax plus b by cx plus d. Okay, y equals to ax plus b by cx plus d. Okay, where here the x belongs to the real values. Okay, here the x belongs to the real values. Okay, and x does not equals to, we can say that x not equals to minus d by, or x not equals to, we can write this is as, so what it is, cx plus d not equals to 0, and x not equals to minus d by c. Okay, if x is equals to minus d by c, we will obtain the resultant as infinity, so which is not defined. Okay, so now how to find out this, the range, the values of x, and the method of this one is called as a method of inversion. Finding the range is called as a method of inversion if it is in the form of linear expression by linear expression. So simply cross multiply and obtain, represent the y in terms of, sorry, represent the x in terms of y. So what it is, if we cross multiply, we will get as ycx plus yd equals to ax plus b. Now represent y in terms of, so represent x. Okay, now we need to find out for x, then we can write as ycx minus ax equals to b minus yd. Then if we take x as a common, we obtain it is as yc minus a equals to b minus yd. So from this one we obtain x is equals to b minus yd by yc minus a. Okay, here the y belongs to the real number, y is also belongs to a real number, and the condition is yc minus a not equals to 0. That means yc not equals to a. That means y is not equals to a by c. Okay, so now what are the possible values of y we are obtaining? Y is all real values, but y not equals to a by c. So we can write the range of the given function which is in the form of a linear by linear. Okay, so the possible values of y can be written as, the possible values of y is nothing but range, so which can be written as y belongs to all the real numbers, but it has does not include the value as a by c, or minus we can write this as the particular value has to be removed from all the real values. Okay, now I think you are able to identify, okay, you are able to identify the range, or you are able to find the range if the function is in the form of a linear by linear. Now we can summarize this as, so how to summarize this? So what is a, if it is any expression in the form of linear by linear, directly we can write the range as what it is, or minus, what is a? A is nothing but coefficient of x in numerator, and c is nothing but coefficient of x in denominator. Then we can write this is as coefficient of x in numerator by coefficient of x in denominator. Okay, coefficient of x in denominator. For example, if we consider the question, let's consider y equals to 2x plus 1 by 1 minus 3x, then what is the range? Directly we can write the range over here. So what is the range? Range is nothing but y belongs to, if this is in the linear by linear form, okay, the function range, the values of y can be directly written as y minus, what is the coefficient of x is 2, and the coefficient of x in denominator is minus 3, then simply it is minus 2 by 3. Okay, we can write this is as, so how, what we can write, the range of the given function y is equals to 2x minus 1 by 1 minus 3x is directly with the help of the short trick what it is, or from the total real values, if it is in the form of linear by linear, from the total real values we need to remove the particular value as coefficient of numerator, coefficient of x in numerator by coefficient of x in denominator. And let's solve another one. What it is, if y equals to 1 minus 3x by and 1 minus 4x, okay, which is also in the form of, yes, linear by linear, then we can write the range, that means y value size from the total real values, coefficient of x in numerator minus 3 by coefficient of x in denominator minus 4, directly we can write it as 3 by 4. or minus 3 by 4, or the range of the given function which is in the form of a linear by linear. So the next type of the fractional functions are either linear by quadratic, or quadratic by linear, or quadratic by quadratic. All these three, okay, only except the linear by linear, just we have seen the method of inversion, and remaining either linear by quadratic, or quadratic by linear, or quadratic by quadratic form type of functions can be solved in the same procedure. These all have the same procedure, so relate same as the what it is the linear by linear. This method is called as converting to quadratic equations. Okay, all these given functions has to be converted into the quadratic equations. For example, let me analyze these type of problems with one example. Now consider y equals to, so x square minus x plus 1 by x square plus x plus 1. Now that means this function is a ratio of two quadratic expressions. So for quadratic expression by quadratic expression, the third type of category. Okay, now how to solve? And here the x belongs to real value only, so we can put all possible values of x over here, then what we get, the possible values of y. Now we need to find the range of y. Okay, now we need to find the range. So we need to find the range means the possible values of x have, sorry, possible values of y have to be find. So for this one, just simply do the what is simply cross multiply this one. What we'll get if we make the cross multiplication directly, I'm writing it as y into x square plus y into x plus y equals to x square minus x plus 1. And we are saying that these all three types are solved with the help of the converting to quadratic. Okay, so the first thing we need to do it as we need to convert. Okay, we need to convert by cross multiplying, we need to convert given expression or given function into quadratic equation. Convert the given function into quadratic equation in variable x. Okay, the first thing we need to do is convert the given function by cross multiplying, convert the given function into a quadratic equation in x. And another important point over here we need to consider is, now this process whatever we are doing is applicable. Okay, this process is applicable only, okay, only when the numerator and denominator do not have the common factor. Applicable only when the numerator and the denominator do not have common factor. Do not have common factor. Okay, so now in this function, the numerator is x square minus x plus 1 and denominator is x square plus x plus 1. These cannot have the common factors. Okay, these cannot have the common factors. Then we can cross multiply the given what is function, and we need to express this in a quadratic equation of variable x. Then how to write this as, we can write this is as y minus 1 into x square. Okay, y minus 1 into x square plus minus x is the plus x, then we can write this as y plus 1 into x plus y minus 1 equals to 0. Now which is in a quadratic equation of variable x, which is in the form of a quadratic equation of variable x, where ax square plus bx plus c, where a is equals to y minus 1, b is equals to y plus 1 and c is equals to also y minus 1. Okay, next what we have to do, and we have considered that the given question has that the x must be real. Okay, so the x is real when the x is nothing but the roots of this function. Okay, the values of this function whatever we apply, so the values of this function whatever we apply, so x is real means, so the if the roots are real and distinct, or the roots are real and equal, what is the discriminant of the quadratic equation? discriminant is must be greater than or equals to 0. If the discriminant greater than or equals to 0, then the values of the variable, the quadratic equation, the values of the quadratic equation variables are real. So we can given that the x is a real value. So to obtain these x values as real, okay, the discriminant must be greater than or equals to 0 is considered. Okay, now find out the discriminant. So what is the discriminant we obtain here? B square minus 4ac. So what it is? Y plus 1 whole square minus 4 times of y minus 1 and y minus 1 equals to 0. Okay, and we can write this is as, how we can write it as y plus 1 whole square minus 4 times of y minus 1 whole square equals to 0. And we can write this is as how to simplify. Okay, we can write the y plus 1 whole square minus, and we can write this is as 2 square. 4 can be 2 square, that means 2 into y minus 1 whole square. Okay, 2 into y minus 1 whole square, that means, and we obtain over here it is as y plus 1 whole square minus 2y minus 2 whole square equals to 0. Now which is in the form of a square minus b square. If it is in the form of a square minus b square, then we can write as a plus b, that means y plus 1 plus 2y minus 2 a plus b into a minus b. So what it is? Y plus 1 minus 2y minus into minus plus 2 equals to 0. Okay, are you getting the student? Just do it as a square minus b square. We can write as some a plus b and a minus b. Okay, now what we'll get here, the resultant as 3y minus 1 is one factor, and another factor is 3 minus y. Okay, so what is another factor? So here it is, we are writing all is equals to 0, but we are finding the discriminant. Discriminant means it is, we need to consider greater than or equals to 0. The discriminant is greater than or equals to 0. We are solving for greater than or equals to 0. Okay, so then we can write this is as, so minus y plus 3 is greater than or equals to 0. Okay, so we obtained in a quadratic equation in variable x, and x is a real. So the real roots we obtained when discriminant is greater than or equals to 0. Then we find it here b square minus 4ac is the discriminant that must be greater than or equals to 0. Then we are finding over here greater than or equals to 0, and inequality is in terms of x, in terms of y we are obtaining. Then what we'll get, if we multiply, if we take minus as a common here, then any inequality is multiplied by the negative sign both sides, the inequality will change. Now which can be written as 3 minus y. If we take minus as a common, then we can write as a y minus 3 minus is greater than or equals to 0. If any inequality is multiplied by the negative sign, the inequality, it changes its inequality, that means greater than or equals to changes to less than or equals to 0. Okay, less than or equals to 0. So now what is 3y minus 1 y minus 3, we are obtaining it as less than or equals to 0. Whenever it is less than or equals to 0, then we can write this is as y belongs to, what is 3y minus 1 equals to 0, that means 1 by 3 and y comma 3. Okay, less than or equals to means that lies in between the smaller and larger value, whereas y equals to 1 by 3 and y is equals to 3, that means we obtain it as a y is equals to 1 by 3 comma 3. Okay, I think you understand how to solve these type of problems. The problem is given that, so if any function is in the form of a quadratic expression by a quadratic expression, so we need to convert the given function into a quadratic equation in variable x. Okay, then, and we need to check for the numerator and denominator do not have a common factor, then convert into the quadratic equations in variable x. We are converting into the quadratic equation in variable x, and x must be a real value. So the real values of x are real only when discriminant is greater than or equals to 0. Then check for the given one, if the discriminant b square minus 4ac is greater than or equals to 0, then we will obtain an inequality in variable y. So the values of y are obtained over here. The values of y are nothing but the range of our required function. The values of y are nothing but the range of our required function. Now what is the range of the given function? What he has given the function y is equals to x square minus x plus 1 by x square plus x plus 1. Now what is the range? The values of y? Y belongs to 1 by 3 comma 3. Okay. Now we are able to find the range of the given function, which is in the form of a linear by linear, linear by quadratic, or quadratic by linear, or quadratic by quadratic. Now we need to check for few things over here. So what are the things we need to consider over here? We obtain the required values. Now here we need to consider some assumptions or some important note we need to consider over here. So if the given function y equals to a1x square plus b1x plus c1 by a2x square plus b2x plus c2. Okay, now if it is in this form, after finding the range, okay, after finding the just before we have seen the example how to find the range. After finding the range, check for, okay, after finding the range, check for y equals to a1 by a2. Okay, check for y equals to a1 by a2 and put that y value. Okay, first point, check for y equals to a1 by a2 and substitute that y or put y, whatever the value obtained, put y in given, okay, put y in what it is given function. Okay, put y in given function and solve for x. Okay, and solve for x. Okay, put the value, check for y equals to a1 by a2. After obtaining the y, then substitute in the given what it is our given function and solve for x. After solving for x, okay, if x is any value we obtained, okay, if some value of x is obtained, x is some value or any value, if some value of x is obtained, we are obtaining some x is equals to some value. Okay, then if some value is obtained, then y equals to a1 by a2 will be in our obtained range, will be in our range, that has to be present in our range. Okay, if x values are not obtained, x is no value, okay, x is having nothing, value of x is obtained while substituting the y is equals to a1 by a2, then the value of y which is equals to a1 by a2 not in our range, okay, not in our, that has not to be in our range. Okay, just again check over here what we are discussing. Here we are discussing that, so we are able to find with the quadratic, converting into the quadratic equation. So any quadratic by quadratic expression form, the function can be converted into a quadratic equation of x. Then we are finding the discriminant b square minus 4ac equals to greater than 0 and we are finding the range. After finding the range, check for y equals to a1 by a2, put that y value in the given function and solve for x. If any value of x is, okay, if some value of x is obtained, then y is equals to a1 by a2 value will be in our range. Okay, if no value of x is obtained, then y is equals to the value what we obtained a1 by a2 is not in our range, okay, in our required range. For example, so here just before what we find it, we find it that y is equals to x square minus x plus 1 by x square plus x plus 1. Okay, So that means compare here a1x square plus b1x plus c1 by a2x square plus b2x plus c2. That means here a1 equals to 1 and a2 equals to 1. The first thing, check a1 by a2. So that means coefficient of x square by coefficient of x square. So the numerator coefficient of x square is 1. As similarly here the denominator coefficient of x square is 1. 1 by 1. That means 1. Okay, we are getting y is equals to 1. Now substitute y is equals to 1 in this function. Okay, and solve for x. So if we substitute y is equals to 1, 1 equals to x square minus x plus 1 by x square plus x plus 1. Now cross multiply over here, what we obtain, x square plus x plus 1 equals to x square minus x plus 1. So that means x square and x square will cancel out, and plus 1 and plus 1 will cancel out, and minus x moves to the what it is LHS. Then we obtain 2x equals to 0. That means x is equals to 0. Okay, we obtained 0 as a value for x. Okay, 0 is a value for x. So some value is obtained. X, we have some value. Okay, if x value is obtained, okay, some value of x is obtained. So if we obtain the some value of x, then y is equals to a1 by a2. What is y is equals to a1 by a2? 1. So the 1 will be in our range of y equals to, y belongs to 1 by 3 to 3. Okay, so 1 will be in this 1 by 3 to 3. We have the 1, and that is the solution. Okay, now check for another condition. If we have y equals to x square plus x plus 2 by x square plus x plus 1. Okay, this is the function. Okay, so and we'll obtain some y value. Okay, y belongs to some range, we'll obtain. Okay, now after obtaining that, check for y is equals to a1 by a2. So that means numerator coefficient of x square by coefficient of x square in numerator by coefficient of x square in denominator. 1 by 1, we are getting y is equals to 1. So now we are getting y is equals to 1 and substitute in the given function. Then what we'll get, and cross multiply x square plus x plus 1 equals to x square plus x plus 2. That means plus x square cancelled out, plus x cancelled out. We are getting 1 equals to 2. This is not possible, and we are getting x is not exist. No value of x is obtained over here. Okay, no value of x is obtained over here. Then y is equals to a1 by a2. This is not in the range what we obtained. Okay, this value is not in a range of the what we obtained over here. I think you understand how to find out these solutions. Okay, now we discussed that. So what it is, y equals to quadratic expression by quadratic expression, x square minus x plus 1 by x square plus x plus 1. And what are the conditions we verified? We verified the first condition is the numerator and denominator do not have a common factor. Okay, that is the condition. Then we need to convert into the quadratic equation in variable x. Then next check for discriminant greater than or equals to 0. Then we will obtain the values of y, that is the range. Okay, that is the range. After obtaining the range, check for y equals to a1 by a2. Put that y in given expression, and if we obtain some value, x is equals to some value, the y must be in our range. Okay, if we do not obtain any value of x, then the y value, y is equals to a1 by a2, not in our range. Okay, this is what we learned up to h. Now here we check for this this procedure is for do not have a common factor. If this is having a common factor, how to solve? Okay, if the given function is having a common factor, how to solve the range of the given function? Okay, now I am considering y equals to x plus 1. We are having the factor size x plus 2 by the denominator. We are having the factor size x plus 2 into x plus 3. Okay, x plus 2 into x plus 3. Okay, now this is the question we are having. It is having a common factor. So that means if we cancel out this, what will get? Y equals to x plus 1 by x plus 3, which is becoming as a linear by linear, but is actually it is a quadratic by quadratic, that is converted into the linear by linear. And here x not equals to minus 2. Okay, if x equals to minus 2, then we'll obtain it is as a infinity, the function is not defined, then x not equals to minus 2. Now we just had seen that how to find out the range of a linear by linear. The y belongs to from the total real values, coefficient of numerator by coefficient of denominator. What is coefficient of x in numerator by coefficient of x in denominator? 1 by 1. Okay, 1 by 1. So we are obtaining the range as r belongs to, that means r values, that means y values are r minus 1. From the total real values, 1, the value 1 has to be removed. But here we need to substitute x is equals to minus 2 in given. Okay, so x is equals to minus 2 in that function. Now what happens if we substitute x is equals to minus 2? Minus 2 plus 1 by minus 2 plus 3. That means minus, what will obtain? Minus 1 by plus 1, which is equals to minus 1. If x is equals to minus 2, we are obtaining it is as minus 1. But x not equals to minus 2, whatever we are applying the inputs, in the inputs x is equals to minus 2 is not present. So if x is equals to minus 2 not present means, but whatever the values we are applying for x is equals to minus 2, then the output of x is equals to minus 2. That means the y values are also not present in range. So that means now for this one, we can write the range as y belongs to r minus 1 comma minus 1. Okay, whereas minus 1 is obtaining by putting x is equals to minus 2. So x is equals to minus 2 is our input. Then whatever the value we substitute x is equals to minus 2, the output is not so also our requirement. The output is not also our requirement. Then we need to remove that whatever the value we obtain by putting x is equals to minus 2 from the range. So now what is our required range for the given function? Y belongs to r minus 1 comma minus 1. Okay, so from the total real values, 1 and minus 1 has to be removed. I think now you understand how to solve if the functions having the common factor. For example, I will consider another one. So if y is equals to, the question is given that x square minus x plus 1 into x plus 1, x plus 2, x plus 3 by x square plus x plus 1 into x plus 1, x plus 2, x plus 3. Okay, now these are the three common factors. Then we can cancel out x plus 1, x plus 2, x plus 2, x plus 3, x plus 3. Now what is the function it is becoming? Y is equals to x square minus x plus 1 by x square plus x plus 1. And how to solve this? Just before we seen that, so these two are not having a common factor. Okay, and next convert into the quadratic equation in x and find out the discriminant greater than or equals to 0. Then we'll obtain y belongs to, what it is, 1 by 3 comma 3. Okay, so this is the values we obtain. But here what it is, x not equals to minus 1. Actually this is the actual function, but the common factors are removed, and x not equals to minus 1, x not equals to minus 2, and x not equals to minus 3. Now substitute x not equals to minus 1 in this given, what it is, obtained equation. So obtained function. So if x is equals to minus 1, then we'll obtain y is equals to 3, and x is equals to minus 2, we obtain y is equals to 7 by 3, and if x is equals to minus 3, we obtain y is equals to 13 by 7. Okay, so but x not equals to minus 1, then y not equals to 3 also. Okay, y not equals to 3 also, and x not equals to minus 2, then the corresponding y value 7 by 3 is also not in our y values, and x not equals to minus 3, and the corresponding y value y is equals to 13 by 7 is also not our requirement. So we obtain the range as y belongs to 1 by 3 comma 3 From these values we need to remove what it is, 3 comma 7 by 3 comma 13 by 7. Now this is the our required solution. Why? Because these x values are not is our requirement, then the corresponding y values are also not is in our range. Those are also not in our range. I think that you understand this concept very well, how to find out the range of a quadratic equations. Okay, how to find out the range of a quadratic equations. Thank you.